This is Monday, week 27's morning work. Let's get to it.
All right, questions 1 and 2 are about dividing mixed numbers. And mixed numbers are when you have a whole number and a fraction together, so 1 and a half, as all one amount is called a mixed number. But we want to make it improper, which means we want our numerator to be bigger than our denominator. Basically, we're going to regroup this in order to divide. And we can divide. We don't have to keep change flip here because our denominators are the same. When your denominators are the same, the numerators can just be divided straight up. All right, now I can clearly see just by understanding division that when you divide something by itself, because 1.5 divided by 1.5, those are the same things. My answer should just be 1, right? It should be 1 and I'm done. But let's prove that that is true and that the rule of division, anything divided by itself equals 1, works out. So let's make them improper. To make them improper, there's a couple things you can do. You can draw a picture where you make a whole and then another whole, cut them both into halves. We're just going to do the mathematical way where you multiply the denominator by the whole number, because what you're doing there is saying, okay, in this amount of wholes, if I cut them each into 2 pieces, how many total pieces would that be? Right, but then, so that would give me 2, but then I also have this 1 extra piece. Remember, this is just a lone piece by itself, and so we're going to add that to 2, which is what we got from 2 times 1, so it goes like that. Okay, so first we stop here, then we keep going into the plus, and so that's going to be 3 halves. And then obviously the other thing is going to be 3 halves as well. And so now all we're doing, since our 2's are the same, we can ignore them, right? We don't even need them. We're just going to do 3 divided by 3. That is our problem. And 3 divided by 3 is 1. Now let's prove that with another method you guys know, which is keep, change, flip. Let's keep 3 halves. Let's change division to multiplication. And then let's do the reciprocal of 3 halves, which is 2/3. Because remember, multiplying by the reciprocal is the same as dividing the original problem, and vice versa. So now we're going to multiply straight across on both numbers, the numerator and the denominator, and we're going to get 6 over 6, which of course, when the top number and the bottom number are the same, what do we have? So it does work. So let's do that again here. 2 times 2 is 4. Plus our 1 is 5, so that's going to be 5 halves, divided by 2 times 1 is 2, plus 1 is 3 halves. And now all I'm going to do is 5 divided by 3, which I can just write like this. And now I'm not done here, because when you notice my answer is improper. We can make them improper, the problem, to divide, especially when we have a denominator that's the same. But let's go ahead and make our answers back to mixed numbers, simplified into the correct version. So how many 3/3 can come out of 5/3? Well, there's 1, and that leaves me 2/3. All right, remember 3/3 equals 1 whole. So I'm going to have 1 and 2/3 as my final answer. So quick review on MAD, mean absolute deviation, is when you have a data set, right? All these numbers, it looks like there's 4 numbers. They have a mean of 8. It already gave us that, but usually you'd have to find the mean first, which is to add up these numbers and divide by 4, because there are 4 numbers. And that puts them into one lump sum and then divides it equally into the 4 groups that are represented by the number of data. So what we're going to do now is make a new list, right, of how far each number is, each number from data, from the 8. So 4 is 4 away from 8. 7 is only 1 away from 8. 10 is 2 away from 8. And 11 is 3 away from 8. Now I find the mean of that. So 4 plus 1 is 5. 2 plus 3 is 5. 5 plus 5 is 10. And now I'm going to do 10 divided by 4, which is going to be 2.5. And that is our MAD. So I want to show this in 2 ways. We can do the cross multiplication, but again, instead of writing 75 hundredths, which I could write 75 over 100 right here, I'm going to simplify. I know 75% is 3/4, right? 25, 50, 75, 100. 4 pieces. So I could do 3x equals 4 times 33, or I could just think of this as equivalent fractions, because this is part to whole and this is part to whole. And so these should be equal in how they are multiplied, right? 3 times 11 equals 33. So 4 times 11 equals x. X equals 44. All right, if you need to rewind that. But I like setting it up that way, the fastest and easiest. However, another method that I didn't go over in the last video is I can divide, since I'm trying to find the whole, when you divide by a piece, and a percentage is a piece, don't be fooled because it says 75. This is 0.75, right? This is 75 hundredths. Percentages are fractions, they're decimals. They're less than a whole. When you divide by a fraction, you get larger. We know that x is greater than 33. 33 is the part, x is the whole, because it says a portion, right? I'm just going to change the language here. A portion of a number we don't know is 33. That means the number we don't know must be greater than 33. So I'm going to do 33 where I'm at, and I'm going to divide by my percentage as a decimal, which I showed down here, and I should get 44. So let's try it out. Can I divide by 0.75? No, so I move the decimal over twice. I'm going to move it over here twice, which makes it 3,300. Right, so 75 into 3,300 is going to be 4, which is 300, right, 150 and 150, leaving me 30, and bring down that 0, and how many 75s can go into 300? 4, with no leftovers. So to find the bigger number, right, if you're given the part and you're looking for the whole, you can take that number and divide by the decimal form of the percentage, and you will get what the original number was. If you were given the total, you would multiply by the percentage and you would be given the piece. But since we have the piece, we're looking for the whole, we can divide. So you can either set it up like this and either cross multiply or just make equivalent fractions, or you can divide. There's always the picture form if you wanted to, which would look like this. And so I make my tape diagram. I know 75% can be broken into 4 25s, so I break it into 4 equal pieces. 25, 50, 75, 100. 75% is 33 of x, right? And so I color that in, and now I'm just taking my 33 and dividing it into the 3 boxes that represent 33, which means each box has to be 11, which means my final box is 11, and so 11 times 4 gives me x, which is 44. For number 5, we just need to get t by itself, right? And so what we can do is we can divide by 64, since it's t times 64, and times 64 divided by 64 cancel out. And then we also have to divide the other side by 64, which is 128 divided by 64 is 2. Okay, so 6 and 7 work together, and we're going to plot these two ordered pairs. And so this will be left 3 up 4, this will be right 2 up 4, and you'll notice they're both up 4. So you're looking for part of it that is the same, right? Either the y coordinates will match or the x coordinates will match for the first part of this calculating distance. And then you're simply going to count how far away these are. So in all reality, I can tell you the distance without plotting them. I know by both being up 4, they're going to make a straight horizontal line, right? I'm going to have, if this is my deal, I'm going to go up 1, 2, 3, 4 and have a point here, and I'm going to go up 1, 2, 3, 4 and have a point here, and so it's going to make a horizontal line, and it's going to go from -3 to +2. So I'm going to have to go 3 spaces to get to 0, and then another 2 spaces to get to my point, so I know the distance between them is 5 units. But let's go plot them and prove it. So I've plotted my -3, +4, and my 2, +4, and now I'm just going to count 1, 2, 3, 4, 5 units apart. All right, so on this one, I set it up this way so that I can show equivalent ratios. I need to get back to the rate. What does one book cost, right? The cost per book. And so I'm going to divide 2736 by my 9 books, and that'll tell me how much one cost. And this was really easy, actually. 27 divided by 9 is 3. And then 36 divided by 9, right, is 4. So I write my 4 as 4 cents, and that would give me 36 cents if I did that 9 times, and $3 9 times would give me $27. So now I'm just going to do $3.04 times 5, and 5 times 4 is 20, and 3 times 4 is 15. So $15.20 is how much 5 books would cost. If y is 2 times x, then y would have to be 8 if x is 4. 3 would have to be y would have to be 6 if x is 3, it would have to be 4 if x is 2, and it would have to be 2 if x is 1. And to get a quick overview on normal or skewed data, you just kind of outline it, and you can see this pretty much looks like a hill. I would say normal. If it was skew, it would be all weird to one side, heavy to one side, and light on the other.